Okay, we're on page 87 in your journal, and we're talking about writing inequalities. And remember, inequalities is a comparison of two quantities using one of these signs, and we'll go over what those mean. So this is a less than sign. Okay, it's pointing, if you made a little arrow out of it, it would be pointing to the lesser side of the number line. And word phrases that you would use would be below and fewer than. Now, of course, there's many more, but these are the most often used. Okay, then we have greater than. That's a greater than sign. Now, you've been doing using these signs for a long time. So you've been doing inequalities for a while. You've been comparing numbers. So word phrases that could use this sign could be above or more than. All right, and you have a less than or equal to sign. So the number could be less than or equal to. It could be either one. Okay, and words like, or word phrases like at most or no more than can be used. All right, and then you have a greater than or equal to sign. And again, remember, you can pause this at any moment if I'm going too fast. So at least is one word phrase that could mean greater than or equal to, or no less than. So an inequality is a mathematical sentence that shows the relationship, okay, if whether it's larger or greater or smaller, less than or greater than, between quantities, okay, numbers, things we're talking about, how many you have of something is a quantity, that are not always equal. So they're not like, these aren't like equations where you have an equal sign and your variable is equivalent to one answer. You have an infinite amount of answers. For example, this is an inequality, and this would be read as x is less than or equal to 3. So that means 3 could go here and be a solution for x, or 2, or 1, or 0, or -1, or -2, or 2.9999999. So a lot of different answers could go here. So with a less than or equal to sign, okay, with a less than or equal to sign, or a greater than or equal to sign, you're going to have a closed circle or a closed dot on 3. And what that means is, if you have a closed dot, that means it can be equal to 3. That's why you have the closed dot there. Okay? That's why you have a closed dot. It can be equal to 3. It's like they took half of an equal sign and put it underneath the less than sign to show that this was less than or equal to 3. So since we know x has to be equal to 3, we closed in our dot, but to be less than 3, we're going to put a line or a ray, R-A-Y, to show that everything where this ray is touching could be a solution for x. Okay? So if you want to check it, you're going to say, okay, well, my line is touching 2 and 1 and a half and 0, and it would touch -1 and -2. So I'm just going to choose randomly 2. Now I'm going to put it in place of x. So I'm going to rewrite that. 2 is less than or equal to 3. And that's true. 2 is less than 3. So my check worked out. I did put my ray in the correct direction. All right, so when you have something like x is less than 3, that means x cannot be 3 because it has to have this little equal to sign here. So it has to be less than 3. So this could be 2.9999999, repeating. That would be less than 3. So it's hard to know where to put our circle. So we're going to put an open circle or an open dot on 3, meaning x can't be 3, but it can be everything to the left of 3 or less than 3. So where this ray is touching, any point on this line could be a solution or an answer for x. So that is an open circle for a less than or greater than sign. All right, so Another way it could give you a situation and have you write an inequality and graph it. So it says a child needs to be at least 48 inches tall to ride the Ferris wheel. So at least right there is really important. So at least 48 inches tall. So I go up here, at least means greater than or equal to. So I'm just going to use x as my variable. So a child's height, it has to be at least. So they could be equal to 48 or taller or greater. So there's my inequality, and now I'm going to graph it. So I could put my 48 basically anywhere I want. I could put it over here, as long as it's on the number line. And again, I can count by anything I want. I'm going to count by ones, but I'm only going to label every other one just so that I have room to work a little bit. So notice my numbers are getting smaller this way and larger this way. So I'm going to have a closed dot, because a closed dot, it means that it could be equal to 48. That child could be that tall, or greater. So I'm going to go in the greater direction on the number line. And that's how I would graph it. All right, this one, the temperature is more than, there are my keywords, more than 2 times yesterday's low temperature of 45. So 2 times 45. So again, I'm just going to use x as my variable. More than means greater than. So greater than 2 times 45. But I can't leave it like that because I need one number here in my inequality so I know where to put my dot. So I'm going to go ahead and simplify this. 2 times 45 is 90. So the temperature, x, is greater than 90. So again, I'm just going to randomly put 90 where I want it to be on the number line. I'm going to count by ones, but I'm only going to write every other one. So since this does not have an equal to sign, it can't be equal to 90. So I'm going to put an open dot on 90, and it says greater than, so I'm going to go toward the greater than side of the number line.